Hello and welcome back. In this video, we're going to work through this example of the eagle rising on a thermal. So just to remind you of this problem, what we're doing here is finding the length of this helical path, this spiral shape, this helical path between t equals 0 and t equals 10. So keep going about this, and we're finding the arc length. So let's return here. And in the last video, I mentioned that in order to get the length of the curve, right, the length of this curve, we integrate from t equal, we're starting from 0 and going to t equals 10 of speed, right? The way to remember this is still distance equals rate times time. So think of that, and then think of the continuous analog of this, right? We're not just going to multiply by time because things are changing. Rather, we're going to integrating the rate over some period of time. So think of it like d equals integral of rate times time, something dt. So like rate times time. But what's really going on here, and what is the rate other than the derivative of this? So what we're doing, or rather the magnitude of the derivative of this, right? Remember, that's representing speed. We want a scalar quantity here. So this is really what we're going to be evaluating. And so let's set this up. So we're integrating from 0 to 10. And then magnitude of r prime. So maybe up here, I'll go ahead and find r prime of t. Or maybe I'll write it down here. Yeah, why not? No. Let's do it up here, and then I'll transfer it down here. So we're integrating, differentiating this. Cosine goes to minus sine, so this is minus 250 sine t. Sine goes to cosine, so this is 250 cosine t. And 100t goes to 100. So notice that it's the rate at which it's moving vertically is constant, right? Constant 100 feet per minute vertically. Okay, so that's what we're integrating with respect to time. So I'll just go ahead and plop this here. Sine of t, 250 cosine t, and give you a chance to calculate this yourself if you haven't. So what have I forgotten here? I've forgotten my magnitude. How did I realize that I'd forgotten something here? Because I was just about to integrate something that I'd just taken a derivative of. And I asked myself, well, aren't I just going to end up with exactly what I started with? Wouldn't I just end up with position? How does that make any sense? We're supposed to get out a length, which is a scalar. So why am I integrating a vector, right? We're not. We should be integrating the magnitude of the vector, which is the speed rather than the velocity. So we're integrating the speed from 0 to 10. So let's go ahead and work out what that is. So that's going to be, here we have integral still 0 to 10. And then the speed of this is square root of, what, 250 squared sine squared t. And then we have, what, 250 squared. Oh, again, I'm treating this like a vector. What am I thinking? This is something that happens sometimes. 250 cosine squared t. And then plus 100 squared dt. Notice the dt is not in the square root here. It wouldn't make a whole lot of sense if it was. Anyway, here we have sine squared plus cosine squared, right? I could pull a 250 out of that. I know sine squared plus cosine squared is 1, so really I just have, this should be 250 squared. Hopefully you caught that too. So I should just have 250 squared here, and then 100 squared over here. So let's see what I have then. I have integral from 0 to 10 of square root of 250 squared plus 100 squared dt. And what was cool when that identity happened, the sine squared t, cosine squared t, is we got rid of our variable t, which means we're just integrating a constant over time. So this is, what, just 10. So this is really a constant speed. That's cool. And so, yeah, it really does come down to distance equals rate times time, because we actually found that this rate was a constant. So it works out in that case as well. So we get what? 10 square root 250 squared plus 100 squared. We can go ahead and calculate that. Remember, it's a good idea to work through these calculations along with me and see if you get the same answer I do. I get 2,692.58. And I'll go, to 2 decimal places of accuracy. And this is in feet. So over those 10 minutes, it travels this many feet. That's the length, remember, of that spiral shape as we go up. That's the actual length of the spiral. Anything else? Nope. That about does it. Good work.